Okay, buckle up because we are diving deep into something pretty spectacular today. We're talking about a giant leap forward in just the mechanics of getting to space.
That's right. This deep dive is specifically focused on Starship Flight 9. We've taken the stack of sources you provided, mission plans, updates, strategic docs, and we're going to pull out the absolute core of what this specific flight test is all about.
Yeah, our mission with these documents is to really cut straight to the heart of it. What makes Flight 9 so important? The basic facts are right there. It's set for May 27, 2025, launching at 6:30 p.m. Central Time.
Which is 11:30 p.m. UTC.
Right, 11:30 UTC from Starbase in Texas.
And our goal here really is to make sure that by the end of our chat, you have a crystal clear picture of why this test is happening, what they're trying to learn, and, well, what the document suggests the bigger implications are.
Exactly. So let's get right into the kind of snapshot of the mission itself based on these sources. Again, May 27th, 6:30 p.m. Central from Starbase. And the flight duration looks like about 1 hour and 6 minutes, give or take.
And the vehicles involved are key. The source's name, Super Heavy Booster 14, or B-14-2. And the upper stage, the Starship. Now this is interesting. One source, the mission plan, calls it Ship 35, a Block 2.
Okay.
But other sources, like the ones on rapid reusability or flight test objectives, they call it Ship 25.
Huh. S-35 versus S-25. Okay, but either way, it's the current Starship upper stage they're flying.
Precisely. It's the latest iteration going up.
And it's not going up empty, right? The sources mention a payload.
Yeah, 8 Starlink mass simulators, totaling around 16,000 kilograms. The plan is for the upper stage to deploy those on a suborbital path.
Got it. Simulating a real deployment. And the end game? Splashdowns?
Yep, planned splashdowns. Booster comes down in the Gulf of Mexico, and the Starship itself continues on quite a bit further to splash down in the Indian Ocean.
Okay, so that's the basic play-by-play. But let's step back. Why this flight? The documents you shared really seem to stress that this one's a major milestone.
It really is.
Yeah.
When you look at the bigger picture presented in these sources, this flight isn't just, another test. It's explicitly tied to their huge goals, making space access scalable, routine.
The whole multiplanetary life vision.
Exactly. And it's a clear example of that engineering philosophy they use. Build it, fly it, see what breaks, fix it, fly again. That whole agile approach.
Test, iterate, improve. So how do the sources say this specific test plugs into those enormous goals, like reducing costs or enabling Mars missions?
Well, by pushing the system like this, in this test environment, they're gathering data that's just vital for, number one, dramatically driving down launch costs. That's huge.
Right.
And it's also about building up the reliability you absolutely need for crew missions.
Yeah.
It paves the way, according to these docs, for actually doing interplanetary travel, Moon, Mars, and building the kind of orbital infrastructure like refueling depots that you'd need.
So the sources frame this test as a really decisive step, making spaceflight more normal.
Affordable.
Yeah, common, affordable, and ultimately transformative. That's the picture they paint. Okay, now this is where it gets incredibly interesting, and it's definitely a headline feature in these documents. Rapid reusability. This is pitched as the very first reflight of a super heavy booster.
That's the one. Booster 14, B-14-2, which previously flew on Flight 7. This is its second trip.
Wow. So what does reusability mean in this specific context? Did they swap out a lot of parts?
Well, the sources explain that B-14-2 went through some pretty extensive checks after Flight 7. But the key thing is, the vast majority of its components stayed on, including, get this, 29 of its 33 Raptor engines.
29 out of 33 are flight-proven and going again.
Exactly. They were cleared and are being reused.
Just think about that. Taking this absolutely enormous rocket stage, checking it over, and sending it right back up. Why is proving this quick turnaround so critical for you, the listener? Why should you care?
It really boils down to scale and economics. Being able to quickly reuse a booster like this is, well, it's essential if you want the high launch rate needed for their really big projects.
Like Starlink.
Exactly. The documents explicitly mention Starlink, which needs tons of launches, and supporting NASA's Artemis missions to the moon with powerful landers.
Which Starship is supposed to be.
Right. And of course, future Mars missions. This reusability isn't just cool engineering. It's framed as the economic key that makes all those ambitious future plans actually feasible.
Makes sense. Now, these sources also make it clear this isn't just about, getting from A to B. They've packed this flight with some pretty innovative experiments happening right there in flight. Let's dig into some of those technical details.
For sure. On the booster side, B-14-2 has several key tests lined up. One is a controlled flip maneuver. They use things like blocked vents on the hot stage adapter to help orient the booster correctly after it separates from the Starship.
Okay, controlling that massive flip. What else?
There's also a boost back burn planned. That's basically firing engines to change its course and make sure it heads towards that safe splashdown zone way out in the Gulf.
Right, trajectory adjustment.
And then there's a high angle of attack descent. They're testing how to use the booster's own shape and atmospheric drag much more effectively to slow down. The idea is to reduce the amount of propellant needed for that final landing burn.
Using the air itself as brakes, essentially. Smart.
Maybe the most nail-biting one? An engine-out landing simulation.
Wait, what? You mean?
Yeah. The sources say they will intentionally shut down one of the 3 center engines, the ones normally used for the landing burn, during that final descent phase.
Wow. Why would they do that?
To test the system's ability to cope. Can it handle an engine failure mid-burn and still successfully complete the maneuver using the remaining engines? It's about testing redundancy.
That's really putting the system through its paces. Okay, so what about the Starship upper stage? It's got its own list of experiments, I assume.
Oh yeah, definitely. A big one is an in-space Raptor engine relight. Just like it sounds, proving they can restart a main engine once it's in the vacuum of space. That's absolutely fundamental if you want to do orbital maneuvers or, head off to the moon or Mars.
Can't get anywhere interesting without being able to relight your engines. Makes sense.
And then you have a whole suite of reentry experiments. These are critical if the Starship itself is ever going to be reusable landing back on Earth.
Okay, what are they looking at specifically during reentry?
Several things, according to the docs. They're testing different approaches to the thermal protection system, the heat shield, different materials like metallic sections, even some actively cooled tiles.
Actively cold. That sounds complex.
It is. And they're even testing removing some tiles deliberately in certain areas.
Removing tiles.
Before reentry.
To see how the structure underneath holds up to the heat and stress. It gives them data on failure margins.
Okay, that's bold. What else on reentry?
They're also checking out the performance, both thermal and structural, of the functional catch fittings. Those are the points on the side of Starship that are designed, eventually, to be grabbed by the launch tower arms.
For the Mechazilla catch. Exactly. Seeing how those hold up during reentry. And they're also stress testing the rear flaps, which do a lot of steering during descent, and also testing new, smoother edges on the tiles. The sources suggest this is to address potential hotspots they might have seen on earlier flights.
So it sounds like all these experiments, booster and ship, are really designed to push the limits, gather data under tough conditions, maybe even simulate failures.
Precisely. It's about finding the edges of the envelope, understanding how things might fail, and ultimately making the whole system more reliable and safer, especially, with the long-term goal of flying people.
And even though these tests end in splashdowns now.
Right. The documents clearly point to that future vision. Upper stages flying all the way back to the launch site and getting caught by those giant robotic arms on the tower.
Yeah.
These experiments are steps on the road to making that happen.
Okay, let's shift gears just a little. The sources also mention the regulatory side of things, FAA involvement.
Yeah, they highlight that the FAA actually granted an expanded launch license for Starship leading up to this flight. It clears the way for potentially up to 25 Starship launches per year from Starbase.
25 a year? That's a lot. That signals a move towards higher frequency, right?
Absolutely. It's a significant step, enabling the kind of flight rate they'll need for those big projects we talked about.
And with more launches, safety protocols probably get updated too.
They do. The sources mentioned the hazard zone for this flight path has been extended out to 1,600 nautical miles.
1,600 miles. That gives you a sense of the energy involved and the distances covered.
It definitely underscores the scale of this kind of test flight and the need for caution.
So if you, listening, want to follow this flight test live,
Yes.
how can people do that based on the sources?
The documents indicate the usual ways. Official SpaceX webcast is the main one, plus updates on their X account, formerly Twitter.
Right, at SpaceX.
And also the XTV app. The webcast itself usually kicks off about 30 minutes before the scheduled liftoff time.
Good to know. So you can watch these experiments potentially unfold in near real time.
Yeah, it's always fascinating to watch.
Okay, so let's just pull this all together. What does all this really mean for you? From reading these documents, it seems clear this isn't just, the 9th Starship test flight. It's a very deliberate, heavily instrumented experimental mission.
That's the key takeaway. They are actively pushing the boundaries on technologies that the sources say are absolutely necessary to make space access routine and way cheaper in the future.
Things like reusing that giant booster stage.
Right, trying out those different heat shield ideas, even intentionally simulating engine failures during landing.
All steps towards that future where space isn't just for billionaires or governments.
Exactly. It's about laying the foundation, piece by piece, test by test, for a future where space access is frequent, affordable, and enables stuff we can barely imagine now. Global internet everywhere, science outposts, maybe even cities on other planets eventually. This flight is presented as a tangible part of building that foundation.
And these sources really hammer home that engineering approach. Test fast, learn fast, iterate. So here's something to think about as you follow the mission updates. What if these specific high stakes tests, the booster reflight working smoothly, that engine out simulation succeeding, the data coming back from those heat shield variations, what if it all yields exactly the data they're hoping for?
How quickly could that accelerate things? How much faster could we get to that future of routine, low-cost space access that these documents keep pointing towards? That's the big question this flight is helping to answer. Keep that thought in mind as you watch.